Hello, everyone. I'm Frank, and welcome to Frank Puzzles. And, well, this is going to be a special treat. This is actually four puzzles for the price of one, uh, one video. Because all these videos are essentially very related to each other. So I'm going to try to do all four of them all at once, and we'll see how that goes. Feel free to take your time doing any of these puzzles. I figured that it'll basically be able to relate one to the other, maybe? I'm not sure, maybe not. These all look very similar, but there might be a lot of differences between them. I'm not sure. Anyways, take that easiness with a grain of salt, though, because these are considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. As a whole, these puzzles were called, I think it's called Rook. It's R-O with an umlaut and a K. And I believe these all come from Norse mythology. Because this first puzzle is called Niffle. And that, I believe, is in reference to Niffle. Oh no, that's Niffle something different. I'm thinking of Nibelung, but that's actually different. I don't know what Niffle is. The other puzzles in this are called, and if you look, if I'm going to change them pretty quickly, but one is Muspel, one is Freyja, and one is Loki. And Freyja and Loki, I know, are both from our gods in Norse mythology. Freyja is the goddess of love and womanhood, femininity. Loki is the trickster god and the god of mischief, chaos, all those things. So, and these are essentially Norse gods. This one, I don't know what Muspel or Niffle is. I thought Niffle was actually a dwarf, but it's actually Nibel. It's a Nibelung, which is the dwarf that made a ring, which essentially people coveted. So kind of similar to the Hobbits, but actually Hobbits sort of took this theme, or Tolkien took these themes and basically created his own story from it, which was actually pretty cool. Um, but they have similarities, right? In which basically I think Nibelung, but the problem is it's not Niffle, right? So, but Nibel and Nibelung, I think it's Belung is actually ring or something like that. So that's the ring of Nibble, but it's not Niffle. So I thought it was Nibble. I thought Nibble was Niffle, but it's actually not. So I don't know who Niffle is or who Muspel is, but Freyja and Loki are both gods in Norse mythology. So I'm assuming it's has to do doing with this specific shape, which I believe is sort of rune-like. But he creates four different unique puzzles from this, and we're going to try them. And we're going to try to do them all in a row, so it's going to be very interesting. We'll see how this goes. Let's start with Niffle then first, because that's the first one given. Niffle by Gerhard 1963. Sorry, I forgot. He's actually a very channel favorite on Setter, and he does a lot of really cool puzzles. So I actually have high hopes for this. But Gerhard 1963 does a lot of really nice puzzles, and he set all four of these puzzles. Anyways, let's get to the rules of Niffle specifically. Standard Sudoku rules apply. The digits 1 through 9 appear in every row, column, and box. Actually, let's go through all the puzzles rules so that we know the differences. In this puzzle, we have region sum lines, where the sum of the digits on a blue line within a particular region must be the same for all of the regions the line passes through. So, for example, these two digits must equal the same as what this digit sums to, which must equal to what these two digits sum to. Because the sum, and another way of putting this is that the box borders divides each region sum line into segments with equal sums, right? Excuse me. Hence they're called region sum lines. So as an example, we could have something along the lines of 2, 6, 8, 1, 7. Or this could also be 2 and 6, or it could be, yeah, something along those lines. As long as all the regions sum to the same value, that's all that matters. And that's region sum lines. We also have, in this puzzle, crop key pairs. I think this is actually going to be common throughout all the puzzles, where digits and cells separated by a black dot are in an n to 1 ratio, where n is the number shown on the dot. If no value is shown, the ratio is 2 to 1, and not all dots are necessarily given. So, for example, between these two cells, there has to be a ratio of 2 to 1 because there is no digit in the black circle. So we know it defaults to 2 to 1. So for example, if this was a 2, this would have to be a 1 or a 4 to maintain the 1 to 2 ratio. However, we also have a 1 to 3 ratio here. So if this is 3, this could be 1 or 9 because these digits have to have a 1 to 3 ratio here. Similarly, this is a 1 to 4 ratio. So if this is, say, this could be either 1 and 4, or it could be 2 and 8, or 8 and 2 here, because these have to be in a 1 to 4 ratio. And that's how crop key pairs work. Let's take a look at the other puzzles. So all the other puzzles are the same, except that the lines are different. So the crop key pair rule set is common throughout all the puzzles, and we have normal Sudoku rules also common throughout the puzzles. But in Moosespel, we have Dutch whisper lines as the lines, and they're all orange. Usually shown as orange lines, adjacent digits along a Dutch whisper line must differ by at least 4. So for example, if this was a 3, this would have to be 7, 8, or 9, because the only digits that are 4 or more away from 3 are specifically 7, 8, or 9. So for Moosespel, again, we still have standard Sudoku rules and the crop key pair rules that we outlined, but also we have the Dutch whispered lines instead of the region sum lines. So that's for Moosespel. For Freja, instead of the Dutch whispered lines or the region sum lines, we have Renband lines, where they're usually shown as purple lines. Digits along a Renband line must form a set of non-repeating consecutive digits in any order. So for example, if this were a valid example for this would be something like 5, 6, and 7, right? Because these are consecutive with each other, and there are no repeats here, right? But it could be in any order, right? So it doesn't actually have to be 5, 6, 7. That order, it could be something like 5, 7, 6, or 6, 7, 5. That's all fine. Or you could have something along the lines of 9, 7, 8, or something. As long as they're consecutive, that will fulfill the Renband, and there's no repeats. And that's how Freja works. She has Renband lines. Now Loki has everything the same with the crop key pairs and the standard Sudoku rules, but his lines are modular. And any set of 3 adjacent digits along a modular line, usually teal in color, has 3 different remainders when divided by 3. So for example, for these 3 cells, and actually any 3 cells along a modular line, they have to contain 1 digit that has a remainder of 0, 1 digit that has, or 1 digit when divided by 3 that has a remainder of 0, 1 digit when divided by 3 has a remainder of 1, and 1 digit that has, when divided by 3, has a remainder of 2. And they could be in any order, too. And that's an example, could be something along the lines of 3, 5, and 7, right? 3, when divided by 3, has a different remainder of 0. 5, when divided by 3, has a remainder of 2. And 7, when divided by 3, has a remainder of 1. So therefore, this works as a potential modular line. And those are all the rules of all four puzzles. And if you notice, the shape is all the same. They have basically standard Sudoku rules and Kropke pairs in common. Where again, you have an n-to-1 ratio if you have a digit in the black Kropke dot. And you also, the default's a 2-to-1 if there's no digit. And they all have different modular lines, but their shapes are all the same. The Kropke pairs are going to be in different spots, though, but that's when it makes sense. Anyways, there's going to be links. Those are all the rules for all four sets all four puzzles. There's going to be links to each of the four puzzles in the description. So you can do them at your leisure, one at a time if you want, or you can do it all in one go, It's up to you. I'm going to try to do it all in one go because just to keep my mind sort of in sync everywhere here. And anyways, I'm going to get started. Let's go. Okay, so the first thing that I see is this is in a 1-to-4 ratio here. So it's either 1-8 or 2-4. Sorry, 1-4 or 2-8. That's a better way of putting it. Since this is 1-4 or 2-8, what can these digits be? Well, 4 and 8 cannot be in a 3-to-1 ratio with any other digits, so these are ruled out there. So if this is 1, this has to be a 4. If this is 2, this has to be 8. If this is 1, this has to be 3. If this is 2, it has to be a 6. Well, the problem if this is 2 is these digits would have to be 6 and 8, and those add up to 14, which is not a singular digit. So that doesn't work if this is 2. Therefore, this must be a 1, which forces this to be 3 and forces this to be 4. That means this is 3 and 4. That adds up to a 7. So this is the region sum line. So these two digits add up to here. This pair, which is 2-to-1 ratio, cannot have a 3 and a 6. So it's either 1-2, 2-4, or 4-8. Well, if it's 1-2, it specifically has to be 1 here, which would force this to be 2. If it's 2-4, this is 2 and this is 4. If it's 4-8, this has to be 4 and this has to be 8. So this is either 1 or 4 in either case. These are all the same digit no matter what. So we're going to color these as the same digit because they sum to the same digit. This is also 1 because these are the same digit. So this is 1 and this is 1. This can no longer be 1, so this has to be 4. So it's with 2 or 8, and this is also 2 or 8. It's the same digit. These are the same digits. So let's make this green, I guess. These are the same digits. We'll make this pink. These are not the same digit, but these are the same digits. We'll make those blue. These are the same digits, so we'll make that orange. Okay, so let's see. How do we solve this? This is in a 1-to-3 ratio, which is in a 1-to-3 ratio with another digit. This then has to be the only digit that can be in between 2 can be in a 1-to-3 ratio with 2 unique digits is only 3, right? 3 can be divided by 3, which would make a 1, or you multiply by 3 and you get 9. No other digit satisfies that. So therefore this is a 3, which means this is 1 or 9. Can't be 1 because of this 1. So this must be 9, which makes that a 9, which makes that a 9. This then has to be 1. Let's see. This must be in a 2-to-1 ratio. And it cannot be 1-2, 2, 4, or 4, 8 because of the 1, 4 already in the column, so this must be 3 and 6. This can't be 3, though, because this orange is the same in these 3 cells, so it must be a 6. So this must be 6, this must be 6, and this must be 6, which forces this to be 3. This cannot be a 3, 6 pair here. And in fact, actually, anyways, this has to be a 4 to 1 ratio. So this is either 2, 1, 4, or 2, 8. Well, 1 can never be in the pink cells because we have a 1 here, and this sees all these pink cells here. It could be 2, 4, or 8, though. So if this is 2, this would have to specifically be 8. But 8 with another digit, that's not 1. So that's 2. This would, if this is 2, this is 8. This would be 3 at minimum then. Therefore, that would add up to 11, which is not possible for a single digit. So this cannot be 2. It could be 4, in which case this is 1. That seems possible. And it could be 8, right? Which would make this 2. And that seems possible also. So this is 4, 8. This is 4, 8. 4 and 8. 4 can go to 2 or 8 here. If this is 8, this would be 4 and 1. That works. But this would be 9 then. So this can never be 8. If this was 8, this would be 4. This would be 1. This would add up to 9. But 9 is not possible because of the greens. Therefore, this cannot be 9. Actually, we can remove the coloring here because we already have those sets. So this cannot be 8. So this could be 2. If this is 2, this is 4, this is 1. So this would be 3, which is possible. If this is 8, this would have to be 2. And it would be in a 2 to 1 ratio with 4. So this could be 6. So if this is 4, again, this cannot be 8, but it could be 2 here. 4, this would be 2 and 1. That would make that 3. Oh, this can't be 6. So this has to be specifically 3, which means this is 2 and 1, which means this has to be in a 1 to 4 ratio with 1. So therefore, this is 4, this is 4, this is 4. Okay. We know this digit is at, okay. This is either 2 or 5 adding up to 6 or 9, but this can't be 6 because the low digits here that could add up to a single digit with 4 obviously can't be 4, but 1 and 3 are removed, so this would only be 2 or 5 adding up to 6 or 9. Cannot be 6 because of this 6, so this must be 9, which makes this a 5. Therefore, these two add up to 9, so we have 1, 8 is possible, but 1 cannot be either of these cells, so that doesn't work. 2, 7 is possible, so it could be 2 and 7. 3 and 6 is not possible because of the 6 in the box. And 4 and 5 could not be possible because neither of these can be 4. So this has to be specifically 2 and 7. Okay. What does this digit add up to? Okay, so this digit cannot be 1 because you have 2 digits adding up to it. 2 unique digits adding up to it. Can't be 1, 2, 3, 4. If it were 5, this would have to be 1 and 4, but 4 is already in the box, so it cannot be 5. It could be 6, and this is 5. That works. Cannot be 7. It could be 8, and this is 7. That works. And it cannot be 9 because of this 9. So this is 6 or 8. This has to be 5 or 7. Okay. What else? 7. Okay, so the remaining digits in box 5 have to be 2, 6, and 8, and 5. 2, 6, 5, and 8. Well, this can't be 2. It can't be 5. Where's the 5 in box 5? It has to be here. So this is a 5, which makes these also 5. Okay, so we can remove those colors because we already have those. We can remove the pink because we have those. This is now 2, 6, or 8. If this is 6, this can't be 1 to 5. It has to be 2 and 4. So then this would be 4 and this would be 2. If this is 6. If this is 8, it could be 2 and 6 or 3 and 5 adding up to 8. So it could be 3 or 5. But I think 2 and 6 doesn't work. If this is 8, this becomes 2, which forces this to be 2. This is also 2, so neither of these could be 2. Right, so this, yeah, if this is 8, so if this is 6, this becomes 2, 4. And this would have to be 2. Right, because this can no longer be 2. So if this is 6, this has to be 2 and 4. Which means this can't be 2, so this must be 2. If this is 8, this must be 2. So either way, this is 2. So these reds are all 2s. Which means this can't be 2, this must be a 3, which makes this 3 and 5, adding up to 8. So this is 7. We already had a 5 here, so there we go. We could have actually solved it that way. This is a 6. These two digits added up equal these two digits. What are the remaining digits in column 4? We have 3, 5, and 6. These can't be 3 because of the 3 here. Therefore, this must be a 3. This has to be 5 or 6, but it can't be 5 here. So this must be 6, which makes that a 5. These two digits add up to 9, because 6 and 3 add up to 9. Also, these two digits have to be 2 and 8. This can't be 2 because of that 2, so this is 8, which makes that a 2. This cannot be 1, 8 to add up to 9. Can't be 3, 6, or 4, 5. It has to be 2, 7. So this is 2, and this is 7. Remaining digits here in column 5 are 7 and 9. So these are 7 and 9. Remaining digits in column 6 are 1 and 8. Okay. Remaining digits in row 4 are 4, 3, and 8. But this can't be 4 here, so this is 3 or 8. This is 3, 4, 8. This cannot be 3, so this is 4 or 8. Remaining digits in row 5 are 4, 8, and 9. So this could be 4 and 8, but it cannot be 9. So these are 4, 8, and 9. Well, remaining digits in row 6 have to be 1 and 6. This can't be 1, so this must be 6, which makes this a 1. Okay. Now we need to figure out how this adds up. Well, if this is 8, that means this has to be 7 or 9. And I guess this could be 8 and 9. So if this is 8, this has to be 9. Okay, what are these that can add up to? 1 and 7 adds up to 8. 1 and 9 adds up to 10. 7 and 8 adds up to 15. 8 and 9 adds up to 17. 3, 4 adds up to 7, so that's out. 3, 8 adds up to 11, that's out. 4, 8 adds up to 12, that's out. And 8, 9, so this has to be 8, 9, and 8, 9 to add up to each other. Because those are the only sums that add up to that are the same. So this is 8, this is 9, this has to be 8, and this has to be 9. This 8 means this can't be 8, so this is 4, which makes that 8. That makes this 4. This has to be a 3. This has to be 1, and this has to be 7. And now we're just doing Sudoku, right? So the remaining digits in row... Actually, let's take a look at... Yes, I thought so. We have a lot of 1s. These 1s are eliminated here, here, and here. The 1 has to be here. Now we have 8 1s, so we know where the last remaining 1 has to be. It has to be here. So those should be all the 1s. 2s. We know 2 cannot be here, 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 or here. So, sorry, here, 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 or here. So this must be a 2. And now we have 8 2s, so we know where the remaining 2 has to be. It has to be here. 3s, we have... None of these can be 3, none of these can be 3, which leaves this to be 3. Now we have 8 3s, where we know where the last 3 has to be. It has to be here. 4s. 4s cannot be here, or here, or here in box 3, so this has to be 4. We have 8 fours now. Where's the last 4? It has to be here. 5s. 5s cannot be here, here, or here in box 7, so this must be 5. 5 cannot be here, here, or here in box 3, so this is a 5. And now we have 8 5s, which means we know where the last 5 has to be. It has to be here. 6s. 6 cannot be here, here. That's not helpful there. So it could be one of these two. Okay, so that's not helpful. We have 7 and 9 remaining in box 1. This can't be 9, so this must be 7, which makes that a 9. That leaves this as an 8, because that's the only digit remaining. The only digit remaining in row 3 has to be a 7. Therefore, that makes that 9. In row 7, we have a 7 and 8 remaining, but this can't be 7, so this is 8, which makes that a 7. Okay, so we should have enough 7s. Yes, we have enough 7s. We have 8 7s now, which means we know where the last 7 is. It has to be here. We have 8s. 8 can be only in one spot in box 7, so it has to be here. And therefore, we have 8 8s now. We know where the last 8 is. It has to be here. Therefore, we know where the 6s are. This has to be a 6. This has to be a 6. And therefore, we have 8 6s. We know the last 6 has to be here. And we just only have 9 left. So that's 9. So that's cool and good. And now we're on to the next one. We're going to muspel. Okay, so let's see. Again, this is Dutch Whispers. Okay. And we have, again, a 3-to-1 ratio with one cell being in a 3-to-1 ratio with 2 other cells. Therefore, this must be a 3. So these are both 1 and 9. And we're not sure which one's which. This doesn't have to follow that area because these two don't see the same. They could be the same digit, so that's fine. This has to be 4 away from 3. So this has to be either 7 or 8 because 9 is not is already taken in the box because of the 1-9 pair. So this is 7 or 8. This could be 7, 8, or 9 though. This is in a 1-to-4 ratio. So it's either 1, 4 or it's 2, 8 here. Same here. This is 1, 4 or 2, 8. 8 cannot be 4 away from 7, 8, or 9. So this cannot be 8 here specifically, which means this can't be 2. Because 2 is only in a 4-to-1 ratio with 8. Okay. Since this is 1, 2, 4, or 8, this also has to be 1, 2, 4, or 8, because those are the only digits are in a 1-to-2 ratio. This also has to be 1, 2, 4, or 8. But these are specifically 4 away from each other. So if that's the case, if this were 1, 2, and 4, the other one would have to be 8. So one of these two digits has to be an 8. Otherwise, it doesn't work, right? If you try to have 1 and 4 next to each other, they're not 4 apart from each other. 2 and 4 doesn't work the same way. 1 and 2 doesn't work the same way. The only digits that could be here are specifically 8 with another digit. So one of these two has to be 8. This has to be in a 1-to-2 ratio with 8. The only digit that can be that way is 4. So this is 4. This has to be 4 different. This has to be at least 4 away from 4. So this has to be 8 also. This digit is in a 4-to-1 ratio with 8. So it must be 2. This has to have a difference of at least 4 with that digit. So this must be an 8. Therefore, we know this is 8 and 2. This is 8 and 4. This can't. Well, okay, we don't know about that. This has a 1-to-3 ratio. And it cannot contain a 2. So it's either 1, 3 or 3, 9. Either way, it has to have a 9. So this is 1, 3, or 9. This is then 1, 3, or 9. But this has to be at least 4 away from 1, 2, or 4. Well, 1 and 3 cannot be 4 away from any of 1, 2, or 4, so this has to be 9. So this is 9, which makes this 3 to have a 1 to 3 ratio. This then is also 1 or 9, but we're not sure which. Okay. This is 2 and 4. This is 8. Let's see, what else do we have? This has to be... 1, 9, 1, 9. That doesn't tell us very much. This is in a 1 to 2 ratio. It can't have an 8, so it could be 1, 2, 2, 4, or 3, 6. But any of those are possible. Same here. Well, this can't be 4 or 8, so it still could be 1, 2. It could be 2 and 4 if that's a 4. And it could be 3 and 6 if this is 3 and that's 6. So this works for all of them. Oh, this has to specifically be 4 away from 2. So this is 6, 7, or 9. 6 is not 4 away from 6, 7, or 9, so that doesn't work there. This is also 4 away from 8, so this has to be 1 through 4. This is 4 away from 4, and it cannot be 8, so it has to only be 9. So this is 9, which means this can't be 9. That forces us to be 1, which makes that a 9. This 9 has to be, this digit has to be 4 away from 9. So this is 1 through 5. It can't be 3. This can't be 9 anymore because of this 9, so this is 7 or 8. This can't be 6, so therefore this can't be 3 here. What other digits do we have? This has to be 1, 2, 4, or 5. So the digits that are 4 away from that are 1 from the 5, or 5, 6, 7, 8. Those all work. This can be 1 to 2 in a 1 to 2 ratio, 2 to 4, 4 and 8, and this could be 3, and that could be 6 as a possibility. Excuse me. Okay, where else do we tackle then? What are the possible digits on the Dutch whisper lines in row 5 and in column 4? And actually in column, let's say what are the digits in on the Dutch whisper lines in box 5. These have to be 1, 4, 5, 6, and 7. But this can't be 1. Right? These are, well, this one is specifically, cannot be 2. It's 4, 5, 6, or 7. Four, 5, 6, and 7. 4 could only be 4 away from 8 or 9, so this can't be 4. 5 could be 4 away from 1 or 9, so this could be 1 and 5. If this is 6, it would have to be next to a 1 or 2. If this is 7, it's next to a 1, 2, or 3. So that's that. What is 4 away from 1, 2, or 3? 1, 2, and 4 are not. Right? Because if you have 1 here, that's not 4 away from 1, 2, or 3. 2 is not 4 away from 1, 2, or 3. And 4 is not 4 away from 1, 2, or 3. This must be then a 6. So this is 6. This has to be 3 then to be a 1 to 2 ratio. And this must be 1 or 2 specifically. Okay. This is 4, 5, 6, and 7. The 4 could be next to an 8. Cannot be 9 there, though. 5 cannot be next to 1 or 9 because those are both taken, so this is not 5. 6 could be next to 2, but not 1. And 7 could be next to 2. Well, okay, this can't be 2. So this doesn't work for any of them except for 4. So this must be 4, which makes this an 8, which makes that 7. This 8 is 4 away from 1, 2, 3, and 4, but it cannot be 1, so this is 2, 3, or 4. This can't be 4 anymore. This can't be 4 anymore. This is a 1, which would be in a 1 to 4 ratio with 4, and 8, which is in a 1 to 4 ratio with 2. If this is interesting, one of these two is an 8. Oh, this is 3. What's 4 away from 3? It cannot be 1. This has to be 8. So therefore, this is 2. This has to be 7 then, because that's the only digit that's 4 away from, well, that's not 8, basically. This can't be 8. This can't be 2. This can't be 2. This can't be 8. Okay, so what are the possibilities here? This is 1, and this is 2. This cannot be 1 here. This is 3 and 6, 4, 2, or 4, 8. That works for any of them. This can't, but these can't be 4 anymore because of this 4. These can't be 7. Okay, so we have 1, 2, 3, 6, and 4, 8. Those all work still. We have 1 or 5 here, which is fine. This cannot be 2. These cannot be 4. So this is either 1, 2, or it's 3, 6. We're not sure which. Okay, remaining digits here. You have 1, 3, 5, 6, and 9. And they all could be those. Well, this cannot be 1 or 3. So 3 has to be one of these two cells. Can 3 ever be here? No. Because if this is 3, this is at most 6 and at least 1. Neither of which are 4 away from 3. So this cannot be 3, which means this has to be the 3. This 3 is 4 away from either only 7, 8, and 9, and this can't be 8 or 9, so this must be 7. 7 is 3 away from, or 4 away from 1, 2, and 3. Cannot be 1, so this is 2 and 3. Well, this can't be 3, so this must be 1 and 2. So we have a 1, 2 pair in column 6 and in box 8. So this can't be 1. This can't be 1 or 2. This must be a 5 then. This can't be 1, 2, or 3, so this must be 8, which makes this a 4. So this is 1, 2. This can't be 5. 5 can only be 4 away from 1 out of the digits possible, so this is 1. This cannot be 1. These can't be 1. Where is the 1 in box 5? It has to be here. So this is 1, which makes that a 9. The 9 is 4 away from 1 through 5, but it can't be 1, 3, or 4, so this is 2 or 5. Oops. This is 2 or 5. This can't be 1, so this must be 2. This 2 cannot be 4 away from 5, so this has to be 6. This can only be 5 now, because it can't be 9. And those are 5 and 9 are the only possibilities. So this is 5, which makes that 9. This cannot be 9, so this is 6 or 7. This can't be 7 because of this 7, so this is a 6. Either of these work for 1 and 2. 8 is only 4 away from 1, 2, 3, 4, and it can't be 2, 3, or 4 because of the digits in the column or the rows, so this must be 1, which can only be 4 away from 1 is 5, 6, 7, 8, and 9, but 7, 8, and 9 are already taken, so this is 5 or 6. 4 away from 3 is 7, 8, and 9, but 8 and 9 are already resolved, therefore this is a 7. And what are these digits? It could be 1, 5, or 6, and it can't be 6, so this is 1 or 5. 1 can be 4 away from 5 or 6, because 7, 8, and 9 are taken, and it can't be 6 here, so this would be 5 if that's the case. So if this is 1, this is 5. If this is 5, it can only be next to 1 or 9, and it can't be 9, so this must be 1 then. So one of these is 1 or 5. This digit can be either 4, 5, or 7. And none of those are 4 away from 5. So this is 4, 5, or 7. but none of those are 4 away from 5, so this has to be a 1, which makes this a 5. Therefore, this has to be 5 or 7. And this could be 4, 5, or 7. This is 4 or 7 specifically. Now, this can't be 1, so that forces this to be 2, which makes that 1. This can't be 2, so this is 3 or 4. This is 4 away from 2. Can't be 7, 8, or 9, so the only possibility is 6 here. So this is 6. And now we just probably do Sudoku. Remaining digits here are 2 and 7. This can't be 7, so this is 2, which makes that 7. Remaining digits here are 1 and 6. This can't be 1, so this is 6, and this is 1. Remaining digit in box 4 is a 6. So this can't be 6, this is 5. That makes this a 4 as the last remaining digit. We have remaining digits here of 2 and 5. So this is 2 or 5 in column 7. In column 6, we have remaining digits of 6 and 9. This can't be 6, so this must be 9, which makes that a 6. In column 5, we have remaining digits of 3, 4, and 7. Actually, let's look at 1s. That looks like we have enough. Yeah. So 1 can't be here. 1 can't be here. Can't be here, can't be here. Where's the 1 in box 1? It has to be here. We have 8 ones remaining. We know where the last 1 has to be. It has to be here. So this is 1. 2s, we don't have that many of, I don't think. Yeah, so that's not helpful. 3s, we don't have that many either. 9s, we have a decent amount, but still questionable. Okay. 8s, no, we don't have that many. 7s, we don't have enough. So this is, okay, let's continue with the columns and the rows. 3, 4, and 7 remaining here. So this is 3, 4, 7, which is any. This is 3, 4, 7. Okay, 6s. We have actually a lot of 6s. 6 can't be here, 6 can't be here, 6 can't be here. Whereas a 6 in box 3, it has to be here. We have 8 6s now. We know where the last 6 is. It's here. Okay. Remaining digits in row 2 are 2, 3, and 5. Well, this can't be 2, so this must be 3 or 5. This can't be... This could be any of them, 2, 3, or 5. Row 3, what are the remaining digits? They are 4, 7, and 8. Well, neither of these can be 4, so this must be a 4. And these have to be 7 or 8. This can't be 7 because of that 7, so this is 8, which makes that a 7. Okay, this can't be 3 because of the 3 in the box. Where can the 9 be in column 8? Can't be any of these. Can't be here. Can't be any of the filled-in digits, so this must be a 9. So this is a 9. This could be 3 or 5 because it can't be 2. Therefore, we have a 3, 5, 3, 5 pair in box 3, which eliminates 3 and 5 in the rest of the box. This can't be 5, so this must be a 2, which makes this a 5. Remaining digits in column 9 are 8 and 9. This can't be 8, so this is 9, which makes that an 8. We have actually 8 9s now. So we know the remaining 9 has to be in a certain spot. It has to be here. So this is a 9. 8s. We know where the 8 has to be in box 1. Because it can't be here. This is filled out. These can't be 8, so it must be here. So this is an 8. And I think that's 8 8s now, right? Yep, we have 8 8s. We know the last 8 it has to be here. So this is an 8. 7s. We know where the 7 has to be in box 7. Can't be any of these, can't be any of these, can't be any of these. It has to be here. So this is 7. Oh, this can't be a 5 because of this 5. So this is 2. Which means this can't be 2. We actually have now, I think, 8 2s, or 7 2s. But we know where the 2 has to be in box 7. Can't be here, can't be here, can't be here. It has to be here. So this is 2. which means we have 8 2s. We know where the last 2 has to be. It has to be here. So this is 2. This cannot be 5 here. This can't be 7 here, so this is a 5. Remaining digits here are 3 and 4 for the row, but this can't be 4 because of this 4, so this must be 3, which makes that a 4. That makes that 7, which makes that 3. This 7 means this can't be 7, so this is 4, which makes that 7. The remaining digit here is a 4, which means this can't be 4, so this is 3. Remaining digits here are 4 and 5. This can't be 5, so this is 4, which makes that a 5. That makes this 3, which makes that 5, which makes that 3. Therefore, this is a 5. And we celebrate. Cool and good. So that is Muspel. Now let's get to Freyja. Okay, let's restart, I guess. Okay. This cell has to be in a 1 to 2 ratio with something and a 1 to 3 ratio with something. The 1 to 3 ratio can be what? 1, 3. So this could be 1 or 3. And if this is 1, this is 3, then this has to be 2. That works. It could be 2, 6. I forgot about 3. If this is 3, this is 1. And this would have to be a 1 to 2 ratio. So that would be 6. But that doesn't work. Because 6 and 1 cannot be in a 4-length rem band together. Right? 1 has to be with 1, 2, 3, 4. So therefore, this cannot be 3 here and 1 here. So we have so far 1, 3, and 2. That works fine. What about 2 being here? If this is 2, this would have to be 6. And therefore, this could be 4. That works. 4 and 6 could be on a rem band together. If this is 3, this could be 9, and this would be 6, and that could work. So this could be 3 and 9, and this is 6. 6 and 9 could be on a 4-length rem band together. 6, 7, 8, 9. What if this is 6? If this is 6, this would have to be 3, and this would be 2, but that would work. So this could be 6, 2, and this is 3. What about if this is 9? If this is 9, 9 cannot be in a 1 to 2 ratio with anything, so that doesn't work. Okay, so these are the possibilities for these 3 cells. Oh, one thing about this. These have to be, we have 2 2-to-1 ratios between 3 cells. One of them is in a 2-to-1 ratio with 2 other cells, and the other 2 are obviously in a 1 to 2 ratio with the center cell. So the only possibilities for these then are 1, 2, 4, 2, 4, 8, or 1, 2, 4, 2, 4, 8. So this is 2 or 4 no matter what. And these, can this ever be 2 and 8 in this set? No, because they are not on a rem band. 2 and 8 cannot form a 4-cell rem band between them, right? 2 goes to at most 5, 2, 3, 4, 5, and 8 goes down to also 5, which is 8, 7, 6, 5. So therefore, this has to be 2. These have to be 1 and 4, and that forms a rem band with 2 and 3. Because the only rem band that has 1 and 4 are specifically 1, 2, 3, 4. These cannot be 2, so this cannot be. So since these can't be 2, this can't be 1 or 4, right? Because it can't be 1 or 4 required a 2 to be with it. So this can't be 1, this can't be 4. We have a 3, 6, 3, 6 pair now in box 4, which eliminates 3 and 6 from the rest of the box. So this can't be 3 or 6. So this is either 3 and 2, or this is 6 and 9. That's very diverse. Okay. This has a 2 on it. This can't be 1 or 4. So the only 5-digit renbands, 5-cell renbands in normal Sudoku with a 2 is 1, 2, 3, 4, 5, or 2, 3, 4, 5, 6. Well, 3 cannot be either of these, so 3 has to be one of these two. We also need at least a 4 and a 5. So 4 is one of these. 5 can be any of these. And then we have a 1 or a 6 involved. So this is 1 or 6. This is 1 or 6. This can't be 1 here. Well, this digit is in a 1 to 2 ratio with this digit. So it cannot be 5, because 5 is never in a 1 to 2 ratio with any normal Sudoku digit. 5 is double of 2.5, which is not a digit. And if you double 5, you get 10, which is not a number digit. If it's 1 here, that would mean it would have to be with 2. But we already have a 2, 3 pair in the box, so this can't be 1. If it's 4, it could be with 8. It cannot be with 2, so this could be work. And if it's 6, it has to be with 3. But we already have a 2, 3 pair in the box, so the 6 doesn't work either. So this is 4 and this is 8. Which means we cannot have a 4 in anywhere else in the box. This is 8. 8 is in on a renban. It has to have a 7. And it could be 6 or 9 as the other digit for a 3-cell renban. This is in a 1 to 4 ratio. The only 1 to 4 ratios are 1 and 4 and 2 and 8. Either way, one of these is 1. The other one is one of these is 1 or 4. This must be 1 or 4. Therefore, we cannot have a 1 or 4 in the rest of the row. So this is 1, 4, or this is specifically 8, and this is 2. So this cannot be 1 here. This is in a 1 to 2 ratio. Still could be a lot of things. Okay, so let's not go there. This is in a 1 to 2 ratio, and it cannot contain a 2. So no 1, 2, no 2, 4. If you try to have 4, 8 here, 4 and 8 cannot be in a 3 to 1 ratio with any digit, so that's not possible. So this has to be 3 and 6. Well, if this is 3, this would have to be 6. And it would have to be 1 or 9 here. But 1 or 9 cannot be in a 3-length renban with 6. So this cannot be 3. Therefore, this is 6. This has to be 3. This must be a 2 because that's the only digit that's in a 3 to 1 ratio with 6. So this is 2. This is 3. This cannot be 3. We do need a 3 still on this renban because 2 and 4 have to connect using 3. And the only place possible now is here. So this is a 3, which makes this 2, which makes this a 3. 2 and 3 have to be with 1 or 4 to form a renban. Right? Yeah, it's either 1, 2, 3 or 2, 3, 4. 6. Well, okay. The remaining digits in row 5 have to be 5, 7, 8, 9. So this is 5, 7, 8, 9. This can't be 8. This is 5, 7, 8, 9, and this is 5, 7, 8, 9. Can 1 ever be on a length 3 renban with 5, 7, or 9? No. So if this is 4, this has to be 1. If this is 8, this has to be 2. So this is 1 or 2 here. Therefore, this renban has to be either 1, 2, or 3, or 2, 3, or 4. Either way, it needs a 3. This can't be 3, so this must be a 3 here, which means this can't be 3. This must be 6, which makes this a 3 to be in a 1 to 2 ratio. The 6 is in a 3 to 1 ratio with 2, so this must be 2 then. This is 3 and 2. We need a 4 on this renban because it's either 1, 2, 3, 4 or 2, 3, 4, 5. Either way, this can't be 4, so this is a 4. And this is 1 or 5 here. This is 1, 2, 3, or okay, 1, 2, or 4 here. The 6 That's actually kind of broad. Oh, this is in a 1 to 2 ratio. Cannot be 1, 2, 2, 4, or 3, 6. It has to be 4, 8. So this is 4 and 8. Which means this can't be 4. This is 1, which makes that a 4, which makes that 1. This can't be 8. 8 is on a Renban with 2 other digits, so it has to be... It cannot be 6 in either of them, because this 6 sees both of them. So this has to be specifically 7 and 9. This can't be 1, therefore it's 2. 2 is in the 1 to... Oh, whoops. Okay, well, let's go back, because we have a problem here. So I removed a 1 and a 4 here, which is not valid, because... Okay, well, that tells us a lot, actually. This actually specifically has to be 2 and 8, because if we tried to make this 1 and 4, that would eliminate all possibilities for that cell. Apologies for that mistake. So this has to be 2 and 8. So this is 2 and 8. This still could be 1, 3, 5, or 6. I think this still works, though. This cannot be 1, 2, or 2, 4. And if it's 4, 8, 4 and 8 cannot be in a 1 to 3 ratio with anything. Therefore, this is 3, 6. So that works. Again, if this is 3, this would have to be 6 with 1 or 9. And 1 cannot be with 6 in a 3-length ring band. And 9 cannot be with 6 in a 3-length ring band. So this can't be 3. This must be 6, which makes that a 3. Therefore, this can't be 3. We do know this. There has to be a 3 on this Renban, so that all follows. So this is 3, which makes that 2, which makes that 3. There has to be a 3 on this 3-length Renban, because we have a 2 on it, so this must be 3, which means this can't be 3. This is 6, this is 3. This 6 is in a 3 to 1 ratio with 2 only, so this is 2. This has to be 2. This is 1 or 4. That's fine. This cannot be 1, 2, cannot be 3, 6, cannot be 2, 4. It has to be 4, 8. So this can't be 4. So this is 8, which makes that 4, which makes that 1, which makes that 4. Therefore, that's a 1. Okay, so that's all kosher now. We have 4, 6 here. Therefore, this must be a 5, which means this can't be 5. This has to be 6. To make this a Renban, this has to be a 5. So this is 2, 3, 4, 5, 6. This is 4, 5, 6. Again, this has to be 7 and 9. 4 has to be one of these two cells, but it can't be here because of that 4, so this must be 4. This is 1 or 5, but it can't be 5 here, so this is 1. This has to be 6, 7, or 9 around this Renban, because it could be either 6, 7, 8, or 7, 8, 9. And it can't be 6 here, so this is 7 or 9. Oops. This is 7 or 9, and this is 6, 7, or 9. But where can the 6 be in box 5? Can't be any of these cells because of the 6's here. So it has to be here. So this is 6, which forces this to be 7, which means this can't be 7. We still need a 7 on this Renban line. The only possible place for the 7 is here. So this is 7. The remaining digits here are 5 and 9. That's fine. This can't be 5 because of that 5. Therefore, this is a 9. So this is a 5. This Renban can only be 5, 6, 7, 8, 9. Well, where can the 8 be? Can't be here, can't be here. This must be an 8. And we now need a 5 or a 7. This can't be 5, so this is 7, which makes that a 5. This 7 means this can't be 7, so this is 9, which makes that a 7 here. What are the remaining digits in row 5? It has to be 8 and 9. This can't be 8 because of that 8, so this is 9, which makes that an 8. How about row 4? We have 4, 7, and 9, but these can't be 4, so this is only place possible for 4 in row 4. These are 7 and 9. In row 6, it has to be 1, 5, and 7. This cannot be 1 or 7. 1 because the 1's in the box, and the 7, 9 pair in the box, so this must be 5. Therefore, this must be 1 or 7. Well, if this is 1 on a Renban, it requires a 2 to be with it, right? But none of these can be 2, so this can never be 1. This has to be a 7, which makes this a 1. The 7 is either 5, 6, 7, 6, 7, 8, or 7, 8, 9. These both cannot be 8, so it has to be 5, 6, and 7. And this can't be 5 or 7, so this has to be 6, which makes this a 5. This renban is 7, 8, 7, or 9. So it's either, again, 5, 6, 7, 6, 7, 8, or 7, 8, 9. Well, 7 cannot be on either of these two cells, and we require 7 on this renban no matter what, so this must be a 7, which makes this a 9. Therefore, this is 5 or 6. Could be 5 and 6. That's possible here. Could be 6, 7, 8. So, but this would be 6, and this would have to be 8, which is not possible. 8 cannot be on this renban. 8 can't be here, and 8 can't be here, so this has to be 5 and 6. So this is 5, this is 6. This is 2, 3 with 1 or 4. That's fine. And now we just do Sudoku, probably. Well, this is kind of limit. Well, no, actually, we just do Sudoku. Remaining digits here are 1 and 3. This can't be 3, so this must be 1, which makes this a 3. Remaining digits here are 2 and 9. This can't be 9, so this is 2, and this is 9. Remaining digits here are 5 and 7. This can't be 7, so this is 5, this is 7. Remaining digits in row 7. Actually, let's see if we have any. Yes, we have possibilities for 1. 1 in box 1 cannot be here or here, and it can't be here because of the renban, so it must be here. So this is a 1. 1 in box 7 cannot be here or here. It can't be here because of this 1, so this must be a 1. We now know where the 1 in box 9 has to be. It has to be here, and we have 8 1s now, so we know where the last one has to be. It has to be here. How many 2s do we have? We don't have enough 2s. 3s, actually 9s look okay. Yep, we have 9. So in box 1, you can't have 9 here or here. This must be a 9. Okay. Okay, in box 7, we can't have 9 here or here, so this must be a 9. And now, well, that's kind of broad still. Okay. This remaining digit has to be a 4. Let's look at row 3. The remaining digits are 6 and 7, but they could be both 6 and 7. Oh, this can't be 7, so this is 6, which makes this 7. Okay, remaining digits in row 7 are 3 and 8. This can't be 3, so this must be 8, which makes that a 3. Remaining digits in row 8 are 2, 3, and 4. Well, 3 cannot be either of these cells, so this must be a 3. This is 2 or 4, but this can't be 4 here, so this must be 2, which makes that a 4. We should actually have a decent amount of 2s now. Yeah, so this can't be 2 here, so therefore this must be 2. We have 8 2s now, which means the last 2, we know where it has to be. It has to be here. 3 seem like a lot. Yep, we have 8 3s now. We know where the last 3 has to be. It has to be here. 4s. We know where the 4 is in box 3. Can't be here, can't be here. It has to be here. Therefore, we have 8 4s now. We know where the last 4 is. It has to be here. 5s. We have 8 5s, so we know where the last 5 is. It has to be here. 6s. We know where the 6 is in box 7. It has to be here. And we also know where it has to be in box 3. It has to be here. 7s. This is the last 7, I think. We have 8 7s. 8s. Well, this is the only place for 8 anymore. So therefore that's an 8, which makes this an 8. And the last 8 has to be here. And then we have 9s, which has to be here and here. And that's the solve for Freyja. And now on to Loki. Loki is the last one. He's the trickster. Okay, so where do we tackle this now? We know, again, anything that's in a 1 to 4 ratio that can be in a 1 to 3 ratio, the only digits are 1 and 2, right? So this is in a 1 to 4 ratio with 4, 8. This 1, 2 can only be in a 1 to 3 ratio with 3 and 6. So either way, this has a modulo of 0. So we'll mark it as blue. If this is 1, this is 4, which makes this 2 or 8. That works. If this is 2, this is 8, which would force this to be 4. We don't know which one's which. This 3 or 6 is in a 1 to 2 ratio with 3 or 6 only. So this is also modulo 0 modulo 3. Interesting. Okay. What does that mean? I'm not really sure. Okay, let's tack the 3 to 1s. Actually, let's attack the 2 to 1s. These are 1, 2, whoops. Cannot be 3 and 6, because this is a 3, 6 pair here. So this has to be 1, 2, 4, or 8, right? Oh. One thing we know is these two have to be different sets, so they have to be different digits. And since these both have to be different digits, the only digit that's in the 3 to 1 ratio with two different digits has to be 3. Right? If you try to make this a 1 to 3 ratio with any other combination, the problem is these two digits would have to be the same. And that's not allowed because of the modular lines, right? We have to have a digit from each of the 3 modular sets. And if these two are the same, they are obviously in the same modular set. So this must be 3. These are 1 and 9. So one of these two is 0 mod 3. The other one is 1 mod 3. So this has to be a 2 mod 3. So this has to be 2 or 8. So if it's 2 or 8, that means this is 1 or 4. So this is 1 mod 3. We're going to make that pink. Therefore, this is the same modularity. This is 2 or 8. 2, 5, or 8, actually. And this has to be 1... We don't know which one this is. This is also 0 mod 3 here. So these cannot be 0 mod 3. This has to be... Okay, so this cannot be 3 or 6, but this could be 3 or 6. Okay, so this is 1 mod 3 or 2 mod 3. We're not sure which. So it could be 1, 2, 4. 3 and 6 are removed from that. So it's 1, 2, 4, or 8. So this is 1, 2, 4, or 8 to be in a 1 to 2 ratio. So this cannot be 2 mod 3. So this has to be 1 mod 3. So this is 1 or 4. 1 could be with 2. 4 could be with 2 or 8. So this has to be a 2 mod 3. This is a 1 mod 3, which forces this to be 1 mod 3, which means this has to be 1 and this has to be 9. So this is a 0 mod 3. 1 is in a 1 to 2 ratio with 2, so this is only. So this is 2. Oh yeah, 9 couldn't be here because of the 1 to 2 ratio. So this is a 2 mod 3, which makes this 8 and 4. So this is also a 1 mod 3. This has to be, this cannot be, could be any of them actually, so that's fine. 3 is in the 1 to 2 ratio with 6 only, so this is a, and this could be either, so this has to be a 1 mod 3, because these are both 2 mod 3s, and this is a 0 mod 3. This cannot be 3 or 6. So it can only be 1, 2, 4, and 8. Well, 4 and 8 cannot be in a 1 to 3 ratio with any digit. So this must be specifically 1 and 2 because they're both in a 1 to 3 ratio with digits. 1 and 2 is in a 3 to 1. So this can't be 1 because if this is 1, this has to be 3. But we already have a 3 in the row. So this is 2, which makes this a 1. This 2 is in a 1 to 3 ratio with 6. And 1 is in a 1 to 3 ratio with 3. This can't be 2 anymore. This has to be 1 mod 3 because we have a 2 mod 3 here and a 0 mod 3. This is a 1 mod 3 and this is a 0 mod 3. So this must be a 2 mod 3. This can't be 6, so therefore this is 3, which makes that 6. 6 is in a 3 to 1 ratio with only 2, so this is 2. 2 is in a 4 to 1 ratio with 8, so this is 8. And 8 is in a 1 to 2 ratio with 4, so this is 4. Therefore, this is a 1 mod 3, and this is a 1 mod 3. This has to be a 2 mod 3, and this is a 2 mod 3. And neither of these can be 8, so this must be 5, and this must be 2. 2 is in a 1 to 2 ratio with 1 or 4, so that's either. This cannot be 1, but it is a 1 mod 3. So it cannot be 7, because 7 is not in a 2 to 1 ratio with anything. Therefore, this is a 4. And this has to be 2 or 8, which is a 2 mod 3, which works. And this is a 1 mod 3, so this has to be 7 then. So this is 7. This is in a 3 to 1 ratio. It cannot be 2, 6. It could be only 1, 3 or 3, 9. Well, this can't be 1 or 3, so this has to be 9, which makes this a 3. So those are both 0 mod 3s. This cannot be 3, 6, or 9, so it cannot be a 0 mod 3 here. So this has to be a 2 mod 3, which makes this a 0 mod 3, and it has to be 6. This is a 2 mod 3, so this is 5 or 8. This is 5 or 8. This is in a 1 to 2 ratio. It cannot be 3, 6, obviously. Can't be 1, 2. Can't be 2, 4. It has to be 4, 8. So this is 4, and this is 8, which makes this a 1 mod 3. One of these has to be a 0 mod 3, but either of them could be. And we need a 2 mod 3 somewhere. This is a 2 mod 3. 2, where is 2 in box 3? Can't be here, can't be any of the red cells. Cannot be these, so it has to be here. So this is a 2, which makes this a 2 mod 3, which makes this a 1 mod 3. We have 3 2 mod 3s in box 5, which eliminates 2 mod 3s in the rest of the box. This cannot be 0 mod 3, so or 2 mod 3, so this was 1 mod 3. That makes this a 2 mod 3. One of these is 3. Where is it in the box? It has to be here. So this is 3, which is a 0 mod 3. This has to be a 1 mod 3. Since this is 1 mod 3... we have 3 2 mod 3s and 3 1 mod 3s in column 5. So the rest are 0 mod 3s. So this is 6 and 9. This is 6 and 9. This has to be 1 and 7. And this is 1 or 7. Well, we have a 1 7 1 7 pair in box 5, which eliminates 1 and 7 from the rest of the box. So this must be 4. This can no longer be 4, so this must be 1. Okay, this is 1 mod 3 because of these 3 digits. We don't have a 1 mod 3. So this is a 1 mod 3, which makes this 1 7 and this 1 7. This is either 1 or 0 mod 3, or sorry, 1 or 2 mod 3. This is 1 or 2 mod 3. This is 0 or 2 mod 3 for both of those. This is 0 or 2 mod 3 for both of these. The remaining digits here have to be both 0 mod 3s because we have 3 1 mod 3s and 3 2 mod 3s in the row. So this is 6 or 9. We now have, this can't be 3 or 6, this has to be 9. We have all the 0 mod 3s in box 6, so this can't be 0 mod 3. It's a 2 mod 3, which means this can't be 2 mod 3. This has to be a 0 mod 3. So this is 6 or 9, not 8. This can't be 6, so this must be 9, which makes this a 6, which makes this a 9. The rest of row 6 cannot contain a 0 mod 3. And where's the 9? The 9 has to be here. So this is a 9, which is a 0 mod 3. We now have, this has to be a 5, because that's the only remaining 2 mod 3 in the row, and this has to be a 1 mod 3, which makes this a 1. So therefore this can't be 1, this is 7, which makes that a 1. This is also a 2 mod 3, because that's the only set remaining in box 6. This has to be a combination of red or pink. So the remaining digit here is 6, and the remaining digits here are 5 and 7. Okay. Okay. What else can we look at? What are the remaining digits in column 7? We have 1, 5, and 9. Well, neither of these can be 1, so this must be a 1. And is the red. So this has to be 5 and 9 here. Well, this can't be 9, so this must be 5, which makes this a 9. Which means this cannot be 2 mod 3, it's a 0 mod 3, and this is a 2 mod 3. Since this is a 0 mod 3, this cannot be 0 mod 3, and it must be a 2 mod 3. And it can't be 2 or 5, therefore this must be 8, which makes this a 5, which makes that 8. This can no longer be a 2 mod 3, so it must be a 1 mod 3. This can't be 1 mod 3 anymore because of the set, so this must be a 2 mod 3. This can't be 2 mod 3. Therefore, this is a 7, and this is a 5. The remaining digits here are 4 and 7. So we have a 4, 7, 4, 7 pair in column 6. Sorry, 4, which eliminates 4 and 7 in the rest of the column. So this is 1, this is 7. This is still 2 or 5 here. We can't have a 2 mod 3 in box 8, so these are remaining 0 mod 3s here. This has to be 6, and this has to be 3. Therefore, this is a 2 mod 3 here, and this must be a 1 mod 3 here. So this is 5, and this is 7. Whereas the 1 in row 3, it has to be here, so this is 1. I think that gives us 8 ones now, right? Yeah, so we know where the last one has to be. It has to be here. So these, and all the ones are 1 mod 3s, obviously. What about 2s? We have any, that's not pinks, twos. Doesn't tell us much information. Threes. Do we have threes? Not really. Nines should be a lot. We have, yeah, we know where the 9 is in box 3 and in box 7. It has to be here in box 3. And it has to be here in box 7. Okay. So now let's look at 6s. We seem to have a decent amount of 6s. But not, oh, we do. Okay, so we know where the 6 is in box in box 9. Can't be here. Can't be here. It has to be here. So this is 6. Well, we have now, I believe, 8 6s now, right? Which tells us where the last 6 has to be. It has to be here. So this is 6. We also now, from that information, know where the 3s are in box 7. Right? Has to be here. I saw it because of the 3 blues, right? These are 3 blues, these are 3 blues. This must be 3 blues. So this is 3. Well, we know where the 3s are now in box 1 then also. Cannot be here, cannot be here, it has to be here. So this is 3, and the last blue, and then, okay, so this can't be pink. This is, yeah. So we know where the last 3 is because we have 8 3s, right? 1, 2, 3, 4, 5, 6, 7, 8. Yep, it has to be here. So this is a 3, which means it's a blue, which means the last digit in row 2 has to be a 2 mod 3. Okay. The last digit here is a 4. So this is a 4, which means it's a 1 mod 3. That makes this a 7, which makes this a 4. Last digit here is a 7. So that must be 7 here. Where is the 7 in box 3? It has to be here. So this is a 7 and a set red. This has to be a pink and a 5. This must be a pink and a 2. 2, not 5. Which makes that 8, which makes that 2. The remaining digits here have to be a 4 and a 8. This can't be 4, so this must be a 4. This has to be an 8. This is a red, and this is a pink. Remaining digits here are 5 and 8, but this can't be 8, so this is 5, which makes this a 2, which makes this a 5. This is a pink, obviously. This has to be a pink and is an 8, and this has to be a pink and is a 2. So this is 8, this is 2. The remaining digit is a red and a 7. The remaining digits here are 8 and 9. This has to be pink, and this has to be, not 8 and 9, 8 and 4. So this has to be 8, and this has to be a 4. And that's how you solve Loki. Pretty cool, actually. Went through essentially similar paths, looking at the Kropke pairs. I think Gerhard said that he enjoyed using these n-to-1 ratios of Kropke pairs, and he did a really good job with these puzzles. It was really nice actually going through all 4 of these puzzles and sort of seeing similar patterns, I guess. They are all very approachable for every one of them. You just have to know sort of the idea of the various different rule sets, I guess. And these are all the solutions for those 4 puzzles, which form the set of Rook. Anyways, I hope you enjoyed this different type of solve. Actually, it's not a different type, but it's just 4 in 1, I guess. But I hope you enjoyed it. And let me know in the comments, actually, if you enjoyed this or if you would prefer them broken out into each other. I felt like because they were very similarly themed, that it would make sense to put them all together in one. But maybe not. I don't know if that makes sense. Anyways, I hope you enjoyed, and I'll see you next time on Frank Puzzles. Take care.